Hey everyone, hope you're doing well. Today we're going to cover about CNN, that is another form of artificial neural network, typically used for images and videos. So let's go a little deeper. This is an agenda that we're going to cover. We will understand that while regular ANN is good for, let's say, any regular, I would say, text based or number based training, but text or number. So, but may not be that much good for images, and that's when this CNN comes into picture. We'll understand some concepts which are part of that CNN: convolution, pooling, and activator function, and all, followed by architecture and some good practices, right? So let's understand that why it is hard for, if you remember, regular neural network, we talked about input layer, output layer, hidden layers, and bunch of functions, right? Which are like feed forward, backward propagation, and things like that. So what happens is that while that can be good for text and numbers, but if it is about images, if you're using NN for that, it's not that you can't do, but it can involve a lot of computation there, because the structure of images is different. So that's when it has been realized that, hey, can we have something different kind of neural networks? That's when this convolution neural network comes into picture, uh, and that's kind of do the scanning like this, so that way it is able to scan and find the pattern in a better way. It uses a matrix based scanning. That way it is more efficient for images. um, so yeah. Basically, I think the more details about it is they're talking about is that, hey, it has a lot of pixels and special structure, so images can go like, corner and then up and down. It can go anywhere, right? So to find those kind of pattern, if we the regular NN may not be the right choice. That's when they you know researchers or scientists introduced about this CNN, and then we are using them a lot. Of course, there are more advanced concepts came in later. We'll talk about maybe some other session, but I think CRN is still a fundamental for training the image-based data. Moving on, it is about little detail about it. So uh, you know, CNNs are basically specialized neural network designed for grid-like data. You can say, I think I talked about matrix, right? So they cannot do scanning like the matrix, and it is more efficient for images or any spatial kind of data than any regular pattern-based or text or numbers-based. They preserve the relationship as well because they need to for a training, and they understand those patterns in a better way. Okay. And I think we're talking about invention, right? So in the late 80s, it got invented by Ian. So, you know, uh, good credit to him that he talked about it and kind of uh, understood that. So now here is a comparison as well, that why this is, the CNN is more efficient for spatial data. Uh, Now, how this work? How convolution works? So they call it kernel function or filter. There's a small matrix that goes sliding over the images, right, and understand the pattern, and it keeps having the computation. Okay, and also called kernel or filter, right? So this keeps scanning the images and keep finding the pattern. Um, all put together, all the kernel put together called feature map. There's a term for it, and there are controls which manages how far it can move and how fast it can move as well, right? So all that comes into picture. There's some code base. So typically, there are two kind of vertical and horizontal. So you will find this 100, or like to find a pattern you will find like, you know, 0 minus 1s 10. So basically the goal is that we learn the pattern on the left side, right side. All that is a concept. So here's a tiny code snippet to get to how to kind of go about it, how to implement this in code. So you can have a look on this as well. There are some Python library have used on that. And again, hyperparameters. I think we spoke in the previous sessions that what are the hyperparameters, right? They're a configuration of the artificial neural network in general, which controls the training. Okay, and you can configure it per your need. So those are the hyperparameters. Now, uh, concepts like pooling and activation functions. Okay, so you know, what is the max pooling, maximum value in a window? Window is like, you know, we talked about pattern, right? So it is like how much, you know, how we are planning to train your model using these images. So all that you can decide, different layers. And there are some activation functions. I think if you remember, we also use ReLU in regular artificial neural network. So they use for these functions are even used here, like softmax for output layer, sigmoid and all, right? They also use here. um, so, you know, one other way to understand polling is that you understand that how much you want to zoom in and zoom out, right? So, if polling is uh, more, so basically you are trying to manage this training of the images. Okay, so you know you are basically not getting too granular there, right? If pooling is more, so you're trying to save some computation, right? If pooling is less, means you're zooming in and you're reading more patterns, right? So but I think pooling also saves, you know, if pooling is there is a more pooling, so it will save more spaces, more basically computation, and you can do training faster, right? So you got to decide that how where it makes sense to have a max pooling or normal pooling, right? So decide the, you know, how much you want to zoom in and zoom out while training the or finding pattern of the images. Here's a you know, architecture you can imagine that how this works, right? How at a high level. So let's say you are you know giving an image to find a pattern, then it will divide that into different matrix mix, you know, filter there, and then it will apply activation function like ReLU, maybe maxpool as well. Uh, then of course, again this convolution layer will come there. Again, there are a bunch of layers to find that hidden patterns, right? Because sometimes just one layer is not enough. Then of course in the last they flatten it, you know, and then they kind of output it that here's my, you know, final one, right? So that's how they typically work for images. Pretty similar to the how they work for regular text and numbers as well, but bit different. The different architecture, if you want to go in more details, right? So it is like advanced thing, like you want to do some kind of fine tuning on there. So yeah, you can check for yourself how to build your first CNN, right? So here is a code using TensorFlow. This is how you can do that. You got to decide or, you know, divide first some APIs. You need to import this TensorFlow Keras. Keras are the APIs which makes this easier. Using TensorFlow easier, so you can use that. And of course, you need to, you know, introduce that what kind of activation function you're using, what kind of you know, pooling you're using, and different bunch of activation function you're using. So that way it will try to learn on its own. Okay. uh, so some of the tips on like how to train it. So um, basically they're saying that use badges and kind of you know uh, there's some other details that you should be keep in mind. Use platinum layer and things like that. So that way you're training this faster. And again, the way to test it, uh, so that you're not underfitting or overfitting, means either you don't have underfitting, basically that you don't have enough data even to train, right? Overfitting is that you don't have diverse data, and you model end up memorizing those instead of learning. So you got to keep testing using, let's say, either epochs after each epoch, right? So you can test that, okay, how I'm doing, right? If it is getting overfitted, then I think you should stop it. uh, so all that you should be keeping in mind to make sure that you're training this model properly. For the takeaways, so I think we discussed that why CNN are important to train the models for spatial architecture like images or videos, all that. um, you know they preserve this structure, and they share the weight using kernels. We talked about how this trains. There are three operations we talked about, like which are part of the training. First is feature detection happens. They find the patterns on the images. Then, of course, to bring non-linearity, use activation functions like ReLUs and others. And polling are basically your zooming out and to save some computations while keeping the key structure. By the way, they're not missing the key structure; they're keeping the key structure. But I think it helps to keep the key structure and learn the pattern. It's like a trade-off, right? So you got to decide that. But generally, pooling helps. And again, uh, you can basically go deeper on understanding more features, uh, and then you can decide how many hidden layers you want. All that will help to decide that how efficiently you're learning the model from those images. And of course, you can also use pre-trained model, right? The other way. It, and you understand, but if you don't want to kind of do it's because there is a lot of computation and investment involved, right? If you're really doing for, especially for LLMs. So I think for practical purposes, while understanding concept is all good, but when you're actually doing it, uh, on a scale, so it is recommended that you use any existing fine-tuned data, because to speed up your stuff and also minimize your expenses or investment. Okay, some additional thing you can read through. There are a bunch of resources across Kaggle, Google, all that. So you can basically understand it and try make your hands dirty. You will figure it out. Keep your concepts clear and good luck. Thank you. Take care.